Hey everyone, and welcome to The Explainer. If you're a professional art director or digital creator working in 2026, you've definitely felt the ground shifting beneath your feet, right? We hear people call modern AI image synthesis magic all the time. But let's be real, generative AI isn't magic. It's a precise symphony of math, physics, and probability. And honestly, that is fantastic news. Because since it's not magic, it's a system you can actually master. Today, we're tearing down the exact mechanics driving the industry right now, so you can stop merely guessing at prompts and start commanding these tools like a pro. Let's get into it. Okay, let's dive into our roadmap for today. We'll start with the science of the magic, move into transformers and cross-attention, compare the heavyweights Midjourney and DALL-E 3, navigate the 2026 copyright laws, look at the economics of AI art, and wrap up with the environment and the 3D future. Part 1, the science of the magic. We are moving way past those old days of pixel-level coding and manual vertex manipulation. To really look under the hood at the true engine of modern image synthesis, we have to ask a pretty fundamental question. How does an AI actually learn to draw? Well, the answer is a fascinating paradox. For a machine to learn how to create a digital masterpiece, it ironically first has to learn how to completely destroy one. This cycle of destruction and creation is the entire framework of diffusion, and it happens in two distinct steps. First up is the forward process, which is the destruction phase. Imagine a perfectly crisp photo of a cat. The model adds infinitesimal amounts of Gaussian noise to this image over many, many steps. By the end, it's mapped to a simple distribution. It's just chaotic, unrecognizable static. Then comes the reverse process, the creation. A neural network, traditionally a unit, is trained to predict the noise that was added at every single step. By learning this mathematical equation of denoising, literally predicting and subtracting that static, the model can start with the screen of random noise and iteratively refine it back into a totally brand new, coherent image. Pretty wild, right? Now, early models tried to denoise raw pixels directly, which was incredibly slow and computationally heavy. The massive breakthrough that gave us efficient tools like Stable Diffusion was moving this whole process into what's called a latent space. You can think of latent space like a highly compressed, purely mathematical representation of an image. By operating inside this space, the AI processes semantic concepts like shapes, lighting, and composition exponentially faster than it ever could by directly denoising individual dots. Basically, it allows the AI to dream in concepts instead of pixels. Moving right along to part 2, transformers and cross-attention. So, the UNet was the original workhorse, but the 2026 standard has fundamentally shifted the architecture of these models. Traditional convolutional networks had a very local focus. They were fantastic at generating highly detailed textures, but they struggled massively with global symmetry. I mean, that's exactly why older AI gave us those terrifying 12-fingered hands. Diffusion transformers, or DEETs, solve this using a self-attention mechanism. Instead of processing an image as a grid of isolated pixels, a DEET calculates a mathematical weight for every part of the image in relation to every other part. It sees the image as a web of relationships. It literally understands that a reflection in a puddle must perfectly match the light source in the sky, even if they are on completely opposite sides of your canvas. Seeing the whole picture at once like this is why modern models output those incredibly cohesive, stunning compositions that older networks just couldn't wrap their heads around. But you might be wondering, how do your words actually shape that denoising process? Well, that happens through cross-attention. This is the crucial bridge linking your text prompt to the visual latent space. When you type in a prompt like neon cyberpunk rain, the cross-attention layers basically talk to the denoising process. They tell the model, hey, give way more mathematical importance to the blue and pink spectrums and look specifically for patterns that resemble vertical streaks of water. It dictates exactly how the noise gets subtracted based directly on your text embeddings. Part 3, Midjourney versus DALL-E 3. Now, what's really interesting here is that while both of these giants share the exact same diffusion DNA, they represent completely different philosophies for commercial art directors. Midjourney is essentially what we call the opinionated artist. Its philosophy is heavily skewed toward aesthetic excellence. It doesn't just draw what you ask, it interprets it through proprietary algorithms that favor high contrast, cinematic lighting, and intense photorealistic texture. It beautifully fills in the gaps of vague prompts, making it unmatched for concept art. On the flip side, DALL-E 3 is the literal illustrator. Its absolute strength is immense semantic precision and literal prompt fidelity. If you ask for a purple squirrel wearing a monocle reading a 1924 newspaper, DALL-E will nail those complex spatial relationships and even render the legible text on the paper. So you choose Midjourney for the vibe, and you choose DALL-E for strict scene logic. All right, part 4, navigating AI copyright law. The tech is stunning, for sure, but as professionals, the magic has definitely hit the reality of the courtroom. The legal landscape has clarified a bit recently. The 2026 Supreme Court ruling in Thaler v. Perlmutter reaffirmed a hard line. Human authorship is a requirement for copyright. Objectively, what this means is that purely AI-generated works, just spit out from a single prompt, lack human authorship and simply cannot be copyrighted in many jurisdictions. So the crucial point for us is how you adapt your workflow. Pure AI generation is out for copyright, but AI-assisted works now occupy a vital legal gray area. For professional commercial work, your goal is proving significant creative control. Basic prompt engineering? Yeah, that's just no longer enough. To protect commercial assets, professionals have to adopt a human-in-the-loop process. This means providing significant creative direction through specific post-processing, deep structural editing, or utilizing tools that show you dictated the exact composition, not just the concept.
Which brings us to part 5, the economics of AI art.
Because these tools have completely democratized high-fidelity generation, the economic realities of the digital art market have shifted dramatically. According to a UNESCO report from early 2026, we have seen a 20 to 25% decline in income for entry-level concept art and stock photography markets. Simple, task-based art, like asking an illustrator to draw a man in a suit drinking coffee, is now virtually instantaneous and essentially free to generate. As a result, the economic value in the industry has completely flipped. The premium is no longer on technical rendering skills, the manual ability to execute pixel-level details or perfectly draw a shadow. Instead, massive value has shifted straight over toward conceptual vision. The industry has seen the rise of the auteur prompt engineer. The highest-paid creatives right now are the ones who can imagine incredible worlds and possess the deep conceptual design skills required to guide the AI to realize that exact vision. And finally, part 6, environment and the 3D future. We have to address the hidden costs of all this generation and exactly where this technology is heading next. Because the magic definitely comes with a massive carbon footprint. Training a single state-of-the-art diffusion model in 2026 can consume upwards of 1.5 gigawatt hours of electricity. To put that into perspective, that is the exact equivalent of powering over 100 homes for an entire year.
So, how do we synthesize all of this into a practical, actionable guide for your commercial projects? First, to secure copyright, you absolutely must utilize tools like ControlNet and InPainting. Using depth maps to pose characters and sketching rough outlines proves that human-in-the-loop significant creative control. Second, to combat that massive energy footprint and improve your inference generation speed, leverage 4-bit quantization. This lets models run on consumer-grade hardware using 70% less memory, which drastically reduces energy consumption during generation. Third, keep your skills adaptable. The industry is rapidly transitioning from static image generation right into real-time video and 3D environment synthesis. And lastly, always verify data provenance. Make sure your tools bake in C2PM metadata, a digital nutrition label that transparently proves an image was AI-generated, which is becoming an industry standard for commercial delivery. We are truly living in a creative post-scarcity era. The defining trait of Midjourney and DALL-E isn't just that they can draw, it's that they have reduced the cost of a visual idea to near zero. It shifts the bottleneck of creativity entirely away from the hand and straight to the mind. So in a post-scarcity world where the cost of a visual idea is near zero, what world will you imagine rendering next? Thank you so much for joining me for this explainer, and I'll see you next time.